Hi, this is Kate, and we're distributing and combining like terms. It is Halloween, and sisters Alice and Claire and their friend Emma are ready to go trick-or-treating. They get their older brother Pete to drive them. However, Pete demands 10% of their candy for his services. At the end of the night, they decide it would be better to organize their candy before removing Pete's 10%, so that everyone gets some of each. They organize their candy into chocolate, hard candy, and caramels. Emma counts all her pieces, Alice counts hers, and Claire counts hers. They want to find their totals for each category, but drawing pictures of candy would be a pain, so they use C for chocolates, H for hard candies, and A for caramels. So Emma's stash looks like this: 20C plus 15H plus 9A. Alice's looks like this, and Claire's looks like this. We want to add all these together, but we only want to add the same kinds of things. It will be helpful to identify these things we call like terms by drawing the same shape around them. That will help us easily identify chocolates, hard candies, and caramels. Looking only at the red squares, there are a total of 70 chocolates. And looking at the blue ovals, there are a total of 50 hard candies. How many caramels are there? Make your selection when you're ready. There are a total of 40 caramels. A little vocabulary here. The number of things is called the coefficient of the term, and the kinds of things represented by letters are called the variables. To summarize, to make an algebraic expression simpler and easier to read, we combine like terms. Only add together the same kinds of things, the like terms. To make it easier, you can inspect them first and draw the same shape around the like terms. Add the coefficients and keep the variables. Here's one we can use to practice. Now, don't be scared by all the different letters and that some of them are squared. We just want to identify the ones that match. Choose the equivalent expression. Here's a hint. There are some xyz terms, there are some ax squared terms, and there are some x terms. Now choose the equivalent expression. You can select the same answer or change your answer. The equivalent expression is choice B. The 9, -20, and 3 add up to -8 xyz. The 11 and 5 add up to 16ax squared, and the -29x's and 5x's add up to -24x's. Remember that Alice, Claire, and Emma still have to decide how much candy to give Pete. He asked for 10% of their haul, so we need to figure out 10% of each type of candy. We'll multiply the 70 chocolates by 0.1, yielding 7. We'll multiply the 50 hard candies by 0.1, giving us 5 hard candies. How many caramels will they give to Pete? They will give 40 times 0.1, or 4 caramels to Pete. What we just did is called the distributive property. We multiplied every term within the parentheses by the factor of 1/10. To summarize, when a number is written next to parentheses, it's trying to tell you that everything within the parentheses should be multiplied. We multiply the coefficients and keep the variables. Now let's simplify 2 times the quantity 3x plus y minus 8z. Take away the quantity 12x minus 8y plus 4z. It can be confusing when there is no number written, like in front of the y and in front of the second set of parentheses. When nothing's written there, it's really just a super secret, invisible 1 that we can write in to make it less confusing. So we want to multiply the terms in the first set of parentheses by 2, multiply the terms within the second set of parentheses by -1. Which line should we write next? Remember that a negative times a positive comes out to be negative, and a negative times a negative comes out to be positive. Make the best choice. Choice A is equivalent. Now we want to combine the like terms. What should we write next? The equivalent expression, combining all the x's together, the y's together, and the z's together, is choice B. And this is as much as we can simplify this particular problem. You've been distributing and combining like terms.